Hey, what's going on, guys? So this is a video that's going to deal with simplifying radicals. So basically, we can just go over that. What a radical is it is anything that involves a square root, the cube root, 27, um, the fourth root. Basically, anything that has this root symbol is a radical. So, but what we're gonna basically mainly focus on is taking the square root. So, a lot of you guys know that the square root of 4 is going to be 2, okay? Because really, the one thing you need to remember is all of the perfect squares, and I'll basically just do from 4 to 100. So it's 4, 9, 16, 25, 36, 49, 64, 81, then 100. So this is the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, and square root of 100 is 10. Okay, so basically, let's get down to it. So if we have a square root of 20, okay, what we want to do in order to simplify this is, if you put this in your calculator as a square root of 20, you would get 4.47. Okay, and that's a rough estimate. It's actually not equal to, so I'm going to change our little symbol. Now, in the world of math, we don't like 4.47 because it's an irrational number. It's an estimate. When you're doing big calculations, you're going to get rounding errors and you're not going to get the right answer. So in mathematics, we like to be precise. Okay, so we have the square root of 20. We want to think of what numbers can we break the number 20 into, aka what are the factors of it. Okay, so I'm going to break down the prime factors of 20. Oops. And actually, I'll do it over here in a little factor tree. So we can do 20 is 2 and 10. 10 becomes 2 and 5. Okay, so the prime factors of 20, or the prime factorization, is 5 times 2 times 2. Okay, now that's good because we can't break the 5 down, we can't break a 2 down, and we can't break another 2 down. So this is our prime factorization of the number 20. Now, if you remember, we're dealing with the square root. So what we're really looking for is how many different numbers have groups of 2, aka are there any couples in here? So if we look, we have a couple of 2's, aka we have 2 2's, okay? Since we're taking the square root, we want to find all the couples. So there's 2 2's, so we can bring them out front, okay? But once you take a couple and it leaves the square root symbol, one of them goes away. So you're just left with 2, and then we have the square root of 5. Okay. In a nutshell, that's kind of like the long drawn out way. So I'll do another one. We'll do the square root of 50. Okay. But over here, I'll do the prime factorization of 50. So it becomes 5, 10, 5, and 2. Okay. So the square root of 50 is equal to the square root of 5 times 5 times 2. Okay. Now again, we're only dealing with square roots for this lesson. So again, we want to find, do any numbers show up twice, aka are there couples? So 5 show up twice. When we take the 5's outside of the square root, we're going to get 5 square root of 2 is your final answer. Okay. Sometimes when you get big numbers, this can get kind of tedious. So basically, the shortcut that I like to tell my students is we'll go back to the square root of 20. Okay. We want to find 2 factors of 20 where one of those factors is our perfect square, or is a perfect square. So all the factors of 20 are 20 and 1, 10 and 2, 4 and 5. Okay. So 2 and 20, 1 and 20, neither of them are a perfect square. Well, 1 is, but we don't care about that. 10 and 2, neither of them are perfect squares. 4 and 5. 4 is a perfect square, so this is the combination we want. So now it becomes the square root of 4 times 5. I didn't change anything mathematically. I just messed with the way it looks to help us out. Now, which one of these numbers is our perfect square? 4 or 5? The answer is 4, so that one can come out front. And when you take a perfect square outside of the square root, you must square it. The square root of 4 is 2, and we're left with square root of 5, which if you look back, is the same thing we got when we did the prime factorization, okay? Both methods are will give you exactly the same answer. It just really matters how you want to do it, okay? So basically, in a nutshell, let's do square root of 12, okay? We want to know the factors of 12 are 12 and 1, 6 and 2, 4 and 3. So right off the bat, this is our lucky combo. So we're going to get the square root of 4 times 3. 4 is the perfect square. Bring it out. We get 2 square root of 3. And that's your answer. Okay. So that is how we simplify square roots or radicals with numbers. We can also do it with variables. Okay. And it follows the same pattern. Since this is the square root, we want to find something that shows up twice. At least twice. So really the square root of x to the 5th is x times x times x times x times x. Okay? Because it's x to the 5th, so it's x multiplied 5 times. Again, square root, let's look for couples. There's one couple. There's two couples. And this guy is a loner. He's hanging out by himself. He's going to stay single. So we have one couple to come out, a second couple to come out. So in all, we have x squared outside, and then we still have this guy inside. So it's just x squared, square root of x. And that's that. Okay? Nothing too crazy. So now for the last one, I'm just going to combine it, and we're going to do a number and some variables. So we have 18, x to the 4th, y to the 3rd. Okay? So let's think of factors of 18. We have 6 and 3. Neither of them are a perfect square. 18 and 1. That's never going to work. Then 9 and 2. I like 9 and 2. 9's a perfect square. So it's 9 times, 9, 2 times x times x times x times x times y times y times y. Okay? Oof, almost dripping down there. So now we know that the 9's a perfect square, so it'll come out front. We have one couple of x, or one group of x's, another group of x's, and one group of y's. Okay? So when we write outside our radical, the square root of 9 is 3. We have one x, one couple of x, two couple of x's, so it's x squared. One couple of y's, so it's just a y. Square root, we still have a 2, and we have a y. So our final answer is 3x squared y, square root of 2y. Okay? And in a nutshell, that's how we simplify radicals. The next video I'm going to do is combining radicals. So hopefully you enjoyed. And I'll be right back.